Hi, my name is Ken Davidian, and welcome to Season 2 of OT in Space, which stands for Organization Theory in Space. In this season, I'm covering one chapter in every video of the Oxford Handbook of Organizational Change and Innovation, second edition, edited by Marshall Scott Poole and Andy Van de Ven. This video covers Chapter 21 of the handbook, entitled Landscape Models of Complex Change. As mentioned in the last video, the application of complexity science to organizational change studies resulted in 4 categories of complexity science models: agent-based models, computational models, dynamical models, and far from equilibrium models. Complex systems conceptualize organizations as a set of interdependent activity choices. Chapter 20 talked to 3 of those types of models, and this chapter, Chapter 21, is devoted entirely to the NK computational models. In this chapter, the authors review recent advances in NK modeling, the strengths and limitations of this type of model, and then look at how recent models are trying to focus more on how the external environment is constructed and changed by activities within the boundaries of the firm. Finally, the chapter addresses new opportunities these extensions present. I will note that this chapter describes the model characteristics, but it does not go into computational or mathematical detail about it. In its general form, the NK landscape has a random combination of value-creating and value-destroying interdependencies. This is important because it makes no assumptions about what those interdependencies look like, allowing the study of competition, collaboration, or coordination between or within organizations. The more complex the interdependencies, the more complex the problem, and the more rugged is the landscape of peaks and valleys in which the organization is trying to maximize performance. The problem of interdependencies is compounded with the limitation of bounded rationality, meaning organizations do not have perfect insight or full information about the landscape. Organizations have to search for landscape peaks, looking for new ways to increase performance. And because of this, the landscape search activities has been likened to innovation. Based on this, the complex systems perspective is all about organizational change and innovation. The NK landscape model is a simulation of complex analytic models that are underdetermined, and it has benefits over closed form analytic models that are too simplistic. NK simulation models are a very popular way to study organizational change as a complex adaptive system. The model's landscape is an analog to the organization's performance function. Organizations try to maximize their fitness to the landscape by climbing out of the valleys and to the top of peaks. Sometimes those peaks are only local maxima, and organizations try to search for better performance by innovating or making organizational changes. If the peaks are steep and the valleys deep, the organizations may find itself at a local maximum and never find a better performing location within the landscape. Table 21.1 in the text gives basic definitions of the NK model terminology. You can pause the video to read all those descriptions. The NK model has been widely used in organizational studies, and some of its most important characteristics are its integrity, applicability, and relevance or interpretability. Model integrity comes from the fact that it is parsimonious and transparent in its assumptions. Because it makes few assumptions, it is easier than other models to understand the results of a given simulation. Modelers understand what is going on and why with this model, which is hard to do with more complex simulation models. And since it is so widely used, results can be compared to baseline results, and those results can be fully replicable by others. Even though it is a fairly simple model, it demonstrates some complex dynamics. Another strength of the model is the number of degrees of freedom available to the researcher to model the external environment, and this allows researchers to validate its internal and external consistency. Finally, the model has been extensively tested and validated with empirical data. Having said this, there's a lot of opportunity for future research to better understand the empirical limits of the model's boundary conditions. The NK framework has been primarily insightful in modeling highly complex decision-making problems encountered during an organization's search for local and global peaks. This search, as we mentioned before, is closely linked to innovation and the tensions between exploration and exploitation. Other insights are related to the relationships between inputs of density of interdependencies and outputs of landscape ruggedness and peak extremes. This relationship means that as interdependencies increase, it may get harder to move an organization away from local landscape positions, thereby increasing the value of exploration versus exploitation, and vice versa. Also, from the relationship between interdependency and landscape peak height, the more complex a landscape, the rarer but more rewarding it becomes to successfully traverse from a starting peak to a higher peak. Other insights are gained when the concept of strategizing is described as the planned movement of an organization from one local peak in the landscape to another peak. Insights of organizational isomorphism, equifinality, and path dependence are also derived from the NK framework. When the landscape is inverted to represent wells instead of peaks, the deeper the well, the higher the tendency of organizations to fall into it, thereby driving a few dominant organizational forms instead of a heterogeneous mixture. When complexity is low, there are fewer landscape peaks, and organizations will tend to end up on the same local peak regardless of their starting point, driving equifinality. When complexity is high, organizations will not end up on the same local peak, but instead, the peak they end up on will be highly dependent on the path they take, giving rise to an increased level of path dependence. Other insights are described in the chapter, including limitations of simple search strategies, organizational design, the effects of multi-authority versus single authority organizational structures, and interdependent structures with respect to ecosystems. The original NK model has been extended to include many different aspects of organizational search and environmental effects, but it still has limitations. There's current debate on whether it should be replaced or extended even further. One limitation is the exogenous nature of the N and K parameters that determine the landscape structure. This exogeneity imposes limitations that can be modeled, but it neglects the way that organizations affect and change their environments. Another limitation is whether the NK landscapes can actually model real-life systems. For example, the empirical evidence is not clear about the relationship between the number of elements N and the ruggedness of the resulting landscape. More empirical work is required to answer these questions, and this is part of a broader discussion of the relevance of empirical data for testing formal models and simulations. For example, empirical measures of real-life interdependencies, such as the average level and distribution of profitability, are at high levels of analysis and do not necessarily apply at the firm level. Other measurements, such as mapping different patent classification systems, require a lot of assumptions that cannot all be validated. Also, patents themselves represent a biased set of selected outcomes resulting from technological searches. As we talked about before, the exogenous nature of the landscape environment in the NK model is a limitation because we know that organizations are affected in many ways by their environment. This is why any extension to the model that brings the environmental effects into the organization can have a significant impact on the model relevance. Extensions to the model, like landscape shaping instead of landscape searching, are being developed. Other extensions look at how forces that shape the environment affect organizational search behavior. One approach, rather than extending the current model, is replacing the NK function with a PN model that varies from the original in a bunch of different ways. Another extension mentioned in the chapter is one where agents can search within their own landscape and within other landscapes as well. This way, agents can change their landscape in ways that reflect real-world situations that are not part of the current NK model. Well, that's it for chapter 21. I hope you enjoyed it as much as I did. And if you did, please consider subscribing and hitting that notification bell. And thank you very much for watching. Bye. OT in Space was produced by IRL, which stands for Impossible Research LLC. IRL conducts process research on the topics of innovation and industry emergence within the space sector context. IRL also offers services of organization theory consulting, research consulting, and STEAM outreach. This video is intended for educational purposes only.